Now find the nth term. Just see this one example, then you will find the sum of the n term. I will ask you, what is the nth? Is it GP? No. Can it be solved by a GP? No. Can I able to write the nth term? No. Then how can we write the nth term of this series? So this is the name is written as method of difference. To find the general term, to find general term or nth term. Let consider this as is equal to t1 plus t2 plus t3 plus t4. Then we will come to the conclusion that is t1 t3 I'm writing as delta u2 delta 1 u3 delta 1 un is equal to t2 minus t1 delta minus 1. Successive term difference are either in AP or GP. Again I will say successive term difference or consecutive term difference are either in AP or GP. Then if it is AP, then what we will consider the nth term. So first I am writing first difference of successive terms are in AP. Successive terms are in AP. Then considered nth term as an square plus bn plus c. If first consecutive term difference, yeah, first successive terms difference, successive terms difference are in GP, then consider Tn is equal to A r ka power n plus b. GP, their common ratio means T2 minus T1, T3 minus T2, T4 minus T3, last is Tn minus Tn, it becomes GP. T3 minus T2 divided by T2 minus T1. This is the R, common ratio of the successive term difference which are in GP. Equal to 3 plus 7 plus 14 plus 24 plus 37, which I have mentioned. Consider the nth term. First of all, see here, 3 plus difference is 7 and 40 difference is 13. Then what is forming an AP whose common difference is 3. So let's consider nth term is equal to a n square plus b n plus c. This must be needed to calculate this variable. So I am placing n is equal to 1. It means first term. First term means a plus b plus c. N is equal to 3 to 40. And there are 3 variables a and b and c. Once let's solve it. So first, second minus first. 3a plus b is equal to 4 is equal to 7. Subtract this. 2a is equal to 3. A is equal to 3 by 2. Then 3a means 3 into 3 by 2 plus b is equal to 4. Means b is equal to 4 minus 9 by 2 minus 1 by 2. Then a plus b plus c, and 3 by 2 minus 1 by 2 plus c is equal to 3, and c is equal to, this is 1, this c becomes 2. So nth term of this series is come to be a value is 3 by 2 n square plus bn means half n plus 2. I'm not satisfied with this nth term. I want to check it how. Let's place n is equal to 4. If t4 comes to be 24, then my answer is correct. For minus 4 into 1 by 2 plus 2. This get cancelled. This become 8 and 24. Yes. Half n plus 2. Now, this is the nth term of the series. Initially, we are not able to find this nth term. But with this method, we are able. What will the sum of the series? S is equal to sigma Tn. N is equal to 1 to n. Sigma Tn I can write it 3 by 2 n square minus half n plus 2. Sigma operator, as you know, distributive, 3 by 2 sigma n square, n is equal to 1 to n, minus half sigma n is equal to 1 to n, and plus 2, or sigma n is equal to 1 to n 2. So I am writing here answer. What will become the answer? 1 by 6 minus half n into n plus 1 by 2, and for this 2 it becomes 2. Just check, as n equal to 2, you will get the value of sum for the first two terms in 10, and your answer is correct. Let's check it. Why to be backside? N is equal to 2 I am placing, so I am getting SC here, 3 by 2 2. See, 2 can suppose 2, so this becomes 5 into 3, this becomes 15 by 2, this is 15 by 2. 4 is equal to 10. Add the first two terms, 3 of this series, whose nth term I am not able to write, but I have told write like this, and I will tell, see how I have written this nth term. So I am writing again, S is equal to second method manual, 3 plus 7 plus second method, and I prefer that you use the first method only, so I have done the first method first only. See, in this I am not able to write the nth term, but with this tricks I am able to write the first terms. But before that you have to understand the series, that the series is, again you know that the common difference is AP, so means 3 7 14, write like this, 3 7 is shifted, becomes second term to third term, 14 is third term, comes below Tn, and Tn shifted right side. Now you subtract it. After subtraction, just check it, what you will get. It becomes 3, this becomes 4, this becomes 7, this becomes 10, this becomes 13, dotted dotted. Tn, this gets subtracted with this, Tn minus 1, and this T1 above is 0 minus Tn. So Tn goes to the left, Tn minus 1. From here to here, you are seeing that the series are in AP. So let's find the sum of the AP whose number of term is n minus 1. See here, 3 plus n minus 1 by 2 twice A. Twice A means 2 into 4 plus n minus 1 common difference is 3. So it becomes 3 plus n minus 1 plus n minus 1 by 2, and this becomes 3n plus 2. Multiply it, 3 plus 3n square by 2. See here, this become 2n minus 3n, this become minus n by 2, and this become minus 2. So Tn is equal to m plus 1. What you are getting there? Plus 2. Okay, let's check again. This is minus 2, and this is 3. This is 8. This is minus 2, minus 6. This become 3n plus 2. This is minus 2. And I am getting plus 1. And it's something I have done wrong. Let's check me. Tn, C value is, this is 1 becomes. Okay. Minus 3n minus n by 2. Okay. This is 2 divided by 2. Okay. So this will becomes 3, and this become plus 2. So you come to know from here that 3n square by 2 minus n by 2 plus 2, an square plus bn plus c. So this is the series whose successive terms are in AP. Now we will take the series whose successive terms are in GP. See here, difference 3, this difference 6, this difference 12. Then what you are finding? The successive term difference are in GP. The first method is write the nth term, A, R. What is R? R is common ratio of GP, 2 to the power n plus B. So again, what is unknown here? A and B. So I need two equations. T1 is equal to twice A plus B. Twice A plus B is equal to 1. Second, when n is equal to 2, it becomes when n I am placing 2, it becomes a 2 square plus b is equal to 4. 2a plus b is equal to 1. 4a plus b is equal to 4. It means subtract this, you will get 2a, and this becomes 3. A is equal to 3 by 2. Place in the first, it becomes 3 plus b is equal to 1. B is equal to minus 2. Now I got the nth term. Nth term I am writing a 3 by 2, 2 ka power n, and b as a minus 2. Or I can write it 3 into 2 ka power n minus 1 minus 2. Let's check n is equal to 3. N equal to 3 means 3, 2, 2 minus 2, 12 minus 2, 10. Okay, correct. Third term is 10. If you want fourth term, n is equal to 4. It becomes 3 into 2 cube. 8 into 3, 24 minus 2, 22. Oh, this is also correct. So you can check it after finding the nth term. Now I am finding the sum of n term. S is equal to sigma Tn. It means sigma 3, 2 ka power n minus 1 minus 2. N is equal to 1 to n. N is equal to 1 to n. So S becomes 3 is outside, n is equal to 1 to n, 2 ka power n minus 1 minus sigma 2, n is equal to 1 to n. See here, 3, when I place 1 minus 1, and this become minus 2n. So this is GP. So GP sum is 1, 2 ka power n minus 1 upon 2 minus 1 is equal to 1 minus 2n. It means 3 into 2 ka power n minus 2n minus 3 is the sum of the series, whose successive terms are in GP, and I am not able to write the nth term by seeing the series. But considering Tn is equal to a into 2 ka power n plus b, I am able to write the nth term. Now I will do how I get this formula. First of all, so this I got from this method only. See here, 1 plus 4 plus second method 10 plus 22. Again I am writing the nth term Tn minus 1 plus Tn. So I am writing S just below it here. I am shifted 1 terms to the right, 1, 4, 10, dotted, dotted, dotted. Here comes Tn plus Tn minus 1 plus Tn. Subtract it, it becomes 0. And see here, 1 plus 3 plus 6 plus 12, dotted, dotted, dotted. Comes here, Tn minus Tn minus 1 minus Tn. So Tn goes to the left, and here becomes 1 plus 3 plus 6 plus 12, dotted, dotted, Tn minus 1. First, again I will say that what you are finding, from where you are finding the GP, from the second term you are finding the GP, 3, 6, 12 from here. So number of terms is n or n minus 1, n minus 1. So I am writing Tn is equal to 1 plus 3, common ratio is 2. Number of terms n minus 1 upon 2 minus 1. It becomes 3 Tn into 2 ka power n minus 1 and minus 3 n plus 1. It becomes minus 2. And what we are getting here? The same thing I am getting here. So from here, not from here, from this method, Tn is equal to 3 into 2 ka power n minus 1 minus 2. I come to the conclusion that whenever the successive terms are in GP, you considered it as a r ka power n plus b, where r is the common ratio of the successive terms which are in GP. It's common ratio. So here successive terms which are in GP whose common ratio is 2. So from here always considered a Tn is equal to a r ka power n plus b.